Welcome to the summary. You made it this far. Congratulations. I hope, working through some of these problems that you've been able to gain a little understanding of how to graph a quadratic when it's in standard form. So in this video, I'm just going to kind of go through, quickly the process that we use to solve a quadratic in standard form, and then as well as to kind of highlight on some common mistakes as well as some tips and tricks. So, first of all, when we're looking in a graph, the first thing we want to do is obviously make sure it's in standard form, label the A, B, and C, then use the formula for the axis of symmetry to identify the axis of symmetry, and then draw that vertical line on your graph. The next is take the x value of that axis of symmetry, because it's a vertical line, so it's only x, plug that into the equation to find your vertex, then find two more points either to the left or to the right of your vertex, plot those points, and then reflect them over, connect all the points, and extend. So it seems pretty simple when I'm just kind of going through memory on that. But let's kind of get through, let's highlight again some of these tips and tricks and get in a little bit more in depth. The main thing, when I say label A, B, and C, remember we have a quadratic, y equals ax squared plus bx plus c. It's so important to have it in this format and to label A equals, B equals, and C equals. I can't even tell you how many common mistakes I see from students when they don't have A, B, and C labeled correctly. So label them. So one, if you can catch a mistake, or a teacher or anybody else can say, oh, this is what you did wrong. And it's very easy to see if you made a mistake at that point. It's also very important for evaluating the end behavior as well as evaluating the axis of symmetry, because the axis of symmetry, the formula, opposite of B divided by 2A. We got to know what B and A are. And for the end behavior, that is all based off of what A is. So we just want to make sure we label and write them down. Trust me, I know it's a little bit more work, but it is helpful. The next thing is using the axis of symmetry. Find the axis of symmetry first. Once you find that axis of symmetry, right? Next one is find the vertex. Find the point that we can use. But when we go ahead and find our 2 points, right? So we find the vertex first point, and then we pick 2 other points, use the axis of symmetry to reflect. And then we can easily graph. I've seen students, they create like 6 different points, and it's a lot of extra work. Just find 2 points and then reflect over the axis of symmetry. Now let's get into the fun stuff, the common mistakes. So a lot of times I see students that have problems with this. Opposite of, so let's say they have an equation, y equals x squared minus 3x plus 5. And so they'd say, oh, it's already opposite, so it's negative 3 over 2 times 1. No, it's not negative. It's not negative b. It's opposite of b. So if b is negative, then it's opposite of negative 3, right? So we got to use the opposite sign. So what I like to do to help prevent that is I like to use parentheses. It's opposite of b. Make sure you put in the full value b, which is negative 3. This just will help a lot of times because that's a very common mistake. The next thing is understanding the end behavior. We can look at a quadratic and already say this graph opens up. Now the graph opens down. So remember, if A is less than 0, then the graph opens down. If A is greater than 0, then the graph opens up. So it's very, very important for us to make sure that we know, does the graph open up or open down? Because a lot of times we'll be plotting all these points, and say, all right, which direction is everything going to be in? So just understanding the end behavior is a very common mistake, because I'll see students, plot points and then they'll put it like in the wrong way or not even create a parabola, some crazy picture of something. This one kind of goes in with the tips and tricks. You got to evaluate the parabola first, and here comes one of the steps that I have. So student says, they don't evaluate the axis of symmetry. They just say, well, I'm just going to plot points. So they get points that look like this. And they say, OK, well, it's going to look something like that, right? Connect them. And they didn't even look to see that, oh, here's the axis of symmetry. Here's the last point. And then I can just reflect over. And actually, I do have a parabola. But if you just pick points on one side and you don't find the axis of symmetry or where the vertex is, you're just going to want to connect those and kind of make like this curvy line kind of thing and not actually produce a parabola. So very, very important to find the vertex first. Find the vertex, axis symmetry. Pick 2 points to the left or to the right. And the last thing, use arrows. It's just a little quirky, mind. Make sure, guys, this parabola extends indefinitely. It continues going on. It really bothers me when I see students just go right through the point and just stop. It's not a segment. It's not ending at that point. It's going to continue indefinitely. So, it's a very small detail, but obviously a lot of mathematics is, that's one of the important things is paying attention to the detail. These parabolas extend indefinitely. A quadratic, again, is a set of infinite many points, and it's going to keep on going on. So there you go, ladies and gentlemen. I hope you took some information out of this course, and I look forward to seeing you in the next one. Thanks.